Welcome to Ask and Learn.
Okay, so this problem is about comparing the heat given, let's see, the heat that is brought into a gas when it undergoes a transition, and it takes a roundabout path going through ABC, and in the other case, it just goes straight from A to C. So it's kind of about comparing those. So let's dive into this. So you want to get Q. Oops, wrong side. Okay, so we know that delta U is the work done on the gas plus the heat added to the gas. So you can isolate Q is delta U minus the work done on the gas. And then the work done by the gas is area under PV. So I'm just kind of laying out like the general principles that we'll use for this problem. Sorry, it's like really hard to write with this neatly with this tablet. I'm still working on it. Okay, so area under PV curve, and then the work done by the gas is the opposite of what's done on the gas. So those are just some things that we'll use. So for first, let's just focus on the work done by the gas when it goes through ABC. So basically, you just need to find the area of like this triangular part from ABC plus the part under that. So like, let me, I guess, draw what I'm saying. So we need to find, this is roughly like what the curve looks like, and we have to get this whole area. So like both the triangle and the rectangle. So just reading off the graph, like, and using the formula, triangle area is half base times height. It's going to be 1/2 times 0.008 meter cubed, because the base goes from 0.01 to 0.002. So the difference is 0.008, and that's at, the height of it is approximately 2.5 times 10 to the 5 pascals. And then there's a little rectangular thing part on the bottom, so that's just 0.08 meter cubed multiplied by 2, not 2, but by 1 times 10 to the 5 pascals. And then when I put this in the calculator, I got 1800 joules. Great. And then that's part 1 of A. And then to get the change in internal energy, what we want to do is do our forever loved NCV delta T. But we have to get delta T because we don't really have any temperature information yet. That's okay. So we can use the formula T equals PV over NR. And then kind of rewrite this like this. So let's get delta T. So that's going to be P final, which is equal to V final. So P at C, which is times V at C, divided by NR minus P at A, V at A divided by NR. So if you just like read off the graph, and then for N use 1/3 and R use 8.32, maybe you'll get what I got, which is 289 Kelvin. And then if you plug that into that 289 into here, and then you plug your CV 1247 and his 1/3, then you might get that delta U is equal to 1201 joules. And so now we have all the ingredients that we need to get the Q. So that's delta U plus the work done by the gas. So I know I said I wrote it as minus, because that's the way I remember the formula, that delta U is the heat added plus the work done on the gas. But now I'm going to write it like this, delta U plus the work done by. So that's just our 1201 joules plus 1800. And you don't even need a calculator. That's 3001, 30,001 joule. Probably don't need that one. Yeah. And then the next part asks, like, well, what if you just go straight from A to C? And so thinking about the math that we did, there's nothing that changed about our delta U. So I'll label this B. Q is equal to delta U minus or plus the work done by the gas. This delta U stays the same. It really just depends on your final and initial state. And so we determined from the last problem that that was 1201 joules. And then the work done by is just the area under the rectangle, ignoring the triangle part. So it's just 0.08 times 1 times 10 to the 5. And this is pascals, and this is meter cubed. And then if you put that into a calculator, maybe you'll get what I got, which is another nice number, 2001 joules. So much less if you don't take all those extra steps.